So the subtopic now is joint variation. Joint variation. Joint variation. Okay, now here's how this one looks like. This joint variation has too many applications. Too many applications are joint variation. Too many real life applications are joint variation. Too many of them. Now look at how it reads. You can say that Z, that's just a variable, varies jointly as X and Y. Or you can say that Z is jointly proportional to X and Y. These two statements are exactly the same thing. Okay, so now in order to write it, you can say that Z is jointly proportional to X, Y. This is X multiplied by Y, basically. Once you have a joint variation, the other independent variables becomes multiplication. So you can write as this is Z is equal to K X Y. So this is the mathematical representation, the general mathematical representation of joint variation. Okay, so now what's the classical example? This shape is what? What shape is that?
A rectangle.
A rectangle, length times width. So many of you have seen too many times that area is what? Area of a rectangle is what?
Length times width.
Length times width. What that then means is that the constant of proportionality K, is 1. That's what it means. But they don't tell you that it is 1. It is 1. So the constant of proportionality for K in area of a rectangle is 1. So K, where K is equal to 1, you have this type of formula. You see? So many formulas has 2 or more variables. Many formulas has 2 or more variables at the same time. Let me draw this example again, and then let me draw this shape again, and you tell me the shape and then the formula. So I'm going to draw something that looks like this. What's the name of this shape?
Cylinder.
Cylinder. Okay, so what's the volume? Volume of a cylinder is what? Volume of a cylinder is base area. Base area multiplied by the perpendicular height. Multiplied by the height. So now what's base area? Base area is what? Circle. Base area will be pi r squared multiplied by the height. That's the volume. So this is another direct variation because it has radius and also has height.
Mr. Cable?
Yes.
When you were writing the volume down, does that say base?
Yes, so this is base area. The volume of a cylinder is the base area multiplied by height. The area of the base. You can say the volume of a cylinder equals to area of the base multiplied by the perpendicular height.
Okay, thank you.
Yes. So, or you can say base area multiplied by height. So base area of a cylinder is usually a circle multiplied by the height. Now, if it is, let me draw another shape. Let me draw another shape. You tell me what it is, or another figure, whatever you call it. What is this shape I just drew? Or figure?
Is it a cube?
It's a cube. It's either a cube or rectangular prism. Okay, A cube is a special example of a rectangular prism. So what's the volume of this? Volume of a rectangular prism is what?
Length times width times height.
Length times width times height. In this case now, what it means is that the volume of a rectangular prism varies jointly as the length, the width, and the height. Three physical quantities, actually four physical quantities: volume, length, width, and height. And in this particular case, if you're writing it in terms of variation, it will just be V equal to K multiplied by L W H, where K is 1. You see, these are how some of these formulas were derived before you start using them.
Mr. K, will K always be 1?
Yes, in specific situations, yes. In specific situation, for example, situation of a rectangular prism, K is 1. In specific example, like what is it called? Cylinder, K is not 1. K is actually pi for cylinder. Am I making sense? The two things that the two numbers that varies there, the thing that you can change are the radius and the height. The pi will always be constant. So I just try to give you some examples of so many quantities that represent joint variation. And we have how many more minutes? What about how many minutes? Is it 15 minutes? Okay, so let's solve one example of joint variation and then we close. Okay? Or we end. So let's solve one example. Okay, let me read this, please. The interest is jointly proportional to the principal and the time. The simple interest of an investment is jointly proportional to the time and the principal. What this means is if you're making an investment in a bank, you drop your money in the bank, let's say savings account. The simple interest is jointly proportional to the time your money stays in the bank and then the actual money, the original amount you dropped in the bank. For example, if you drop $500 in a bank for savings, are you going to get as much interest as somebody who deposited $5,000? Yes or no? You see? So simple interest for an investment is jointly proportional to the time and the principal. So now this is an example. This is an example. Interest is jointly proportional to principal and time. It means that interest is equal to K principal time times time. The principal is the original investment you make. The time is how long it takes for that investment to mature. You can ask your parents about investment. Some of them have 401k, some of them have retirement benefits, you know, from their place of work. Some of them have various types of investment that they make, like including savings accounts. Once you open a savings account, you are making an investment right there. You are keeping your money for somebody else to hold it for you for over a period of time. And if that money is calculated in simple interest, this is the formula. Okay, so now let's solve an example, a specific example. So let me read again. The simple interest for an investment is jointly proportional to time and the principal, which is what we just wrote here. This is our formula. After 1 quarter, which is 3 months, after 3 months, the interest on a principal of $5,000 is $43.75. So after 3 months, so it means time is 3 months. How many is 3 months in terms of year? 3 months in terms of year would be what? 3/12, which is 1/4. That's time. The interest on a principal is on a principal of 5,000. So P is 5,000. These are given figures. These are given figures. The interest is an I is $43.75. Okay. So now let's find K. Let's find K. K would be interest is $43.75. Just plug in the number. So you have 43.75 is equal to K is, we don't know. That's what we are looking for. And the principal is 5,000. 5,000. And then the time is, they usually do investment per year, which is 1/4. 1/4, you can do it in fraction. What is 1/4 in fraction?
75.
Okay, it's 0.
That's decimal, Mr. UK.
1/4, is it 0. Is it 25 or 75?
25.
25.
Yeah, thank you. 0.25. So, like Javier suggested, we can just multiply out 5,000. We can just multiply out 5,000. Hold on a second, please. So now let's just multiply 5,000 by 0.25. Multiply by 0.25. So that's 1,250. So we have K equal to, no, multiply by 1,250. That's 4,375. So for us to get K, we just divide both sides by 1,250. 1250. 1250. So that gives us our K. All right. So we have 43.75 divided by 1250. So that's 0.035. 0.035 is equal to K. Now here's the question. The question says, find P. When P is 5,000, T is this. Okay, what's the question again? So we can just write the general equation. Let's just write the general equation and end it there. Let's just say that the general equation that the bank will use would be I is equal to 0.35 0.035 multiplied by the principal P multiplied by time. This is P times time. So this is the general formula that the bank will be using. So what that thing means is, once you are given the principal and you're given the time, you can always calculate the interest. That's what it means. Okay. If we say now if somebody dropped, let's say 15,000. Somebody dropped $15,000 in 1 year. Let's just say 1 year instead of 3 months. Somebody dropped 15,000. So if P is 15,000 and time is 1 year. So if P is equal to 15,000 and time is, you can use the time in months if you want. Do you want us to do month or year so that we can end this thing? Hello?
In months.
Okay, so let's say 6 months or the same 3 months. You want 3 months or 6 months?
6 months.
6 months will be 0.5 and time is 6 months. So, and so that would be interest now would be principal 0.035 multiplied by 15,000 multiplied by 6 months is 0.5. So punching the number, that would be, let me type it out, 0.035 multiplied by 1500 multiplied by 0.5. That's $262.50. The interest is going to yield will be $262.50. So this is what the bank does every single day. Every single day, including now. This is what is happening behind the scene. They either do simple interest or they do compound interest. It depends. Even when you buy cars, some of you you've seen parents buy cars. If you have a car note, what they call car notes, a car is sold $15,000, and you don't have the entire money to pay, and they say you can be making monthly payment. This is how much they are going to add into the real value of the car. So by the time they do their simple interest or the compound interest, they will tell you the car that is costing $15,000, you end up paying something like $18,000, but you pay it over a period of time. You see, the same thing happens in houses, real estate. If you buy in a house of $400,000, by the time you pay it in 30 years, you'll be paying about $1 million. That's real. If you have $400,000, you just buy it and it becomes yours. You just pay. But you probably don't have $400,000. So then they give you a 30-year mortgage. So by the time they calculate the interest, you'll be paying more than $1 million. You see? This is real. This is real mathematics we just did.